Good evening, everyone. My name is Rishita Sharma, and I'm delighted to welcome you all to this online webinar hosted by Space India on the occasion of National Science Day. Space India, founded in 2001 by Dr. Sachin Bamba, is a pioneer in science and technology education, focusing on astronomy, space science, and STEM. With a 23-year legacy, it has engaged over 1.5 million students through programs like Universe in the School program and the Innovators Club. Emphasizing experiential learning, Space is dedicated to promoting scientific literacy and curiosity, making it a key player in India's science education landscape. Today, we gather to explore the life and legacy of Dr. C.V. Raman. Dr. Chandrasekhar Venkata Raman was an eminent Indian physicist who won the Nobel Prize in Physics in 1930. That too for his groundbreaking work in the field of light scattering. His discoveries have left indelible mark on the world of science. Our esteemed speaker for today's webinar is none other than Mr. Vikrant Narang, the Chief Technology Officer of Space India. Mr. Vikrant Narang, CTO at Space India, a passionate educator and astronomer. He has an MSc in Space Science and Management from France and has played a pivotal role in establishing an innovative astronomical observatory in NCR. He is dedicated to inspiring future generations in the field of astronomy, and we are honored to have his share insights on Dr. C.V. Raman's contributions and their impact on the scientific community. Without further ado, let's delve into the fascinating journey of one of the greatest scientists. Over to you, Mr. Narang. But before I give the platform to Sir, I request all the audience to pin. There is a comment section. There is a sheet pinned to the comment section. You can fill out your questions over there. And meanwhile, Sir will start, and then we'll have a question and answer in the end. So good to go, Sir.
Hi, very good evening to all the participants who have joined from all over India. It's an honor to be here on the occasion of National Science Day and to be giving this webinar. It's an emotional moment for me to learn so much about Sir CV Raman, and it's truly an honor. So I would once again like to thank all the people who have gathered here on this occasion. And at the start, I would like to wish everyone a very happy National Science Day today. Today, right this day in 1928, that means nearly 100 years back, the discovery of Raman effect happened, for which Sir CV Raman was awarded the Nobel Prize in Physics in 1930. And today we are commemorating that day. And the theme for this year's National Science Day is innovative indigenous technologies for a Viksit Bharat. The theme is basically emphasizing the need for India to develop indigenous technologies. To give you some example of indigenous technologies, we have sent Chandrayaan, which was indigenously built. So India is standing on the platform where we are actually developing our indigenous technologies. And particularly I feel when we talk about rockets as indigenous technologies, no country could have given us the rocket technology of rocket. So without this pillar, we could not have gone to space. And particularly, I want to mention that Sir CV, I felt this is an amazing link to what Sir CV Raman stood for. He stood for developing equipment in India. So, he stood that we have incredible people in India. So why we are buying technologies for laboratories from outside when we can make them at a fraction of cost right here in India. So today I hope you will sit back, relax, and enjoy the presentation and the webinar which I'm going to give you. So I will be dividing it into two parts. The first part is life of Dr. CV Raman, and the second part is about the legacy. That means the discovery of the Raman effect. We will also, I hope this will inspire interest in science for all of you. At the start, I would also like to share a quote from Dr. APJ Abdul Kalam, who says, "Science is all about asking questions, finding the right answers through hard work and research into the laws of nature. Keep asking questions till you get satisfactory answers. Only questioning minds have made the world a livable place in spite of the world's non-linear dynamics. So imagine what would the world have been like. Imagine if you start imagining world if there was no science. So if you imagine no, you will slowly everything you know of possible will not be existing. No technology would exist. So if you think about it carefully, suppose you eliminate the technology or the science behind light bulb, there would be no light. If you eliminate the technology behind science, electricity, there would be no electricity and no gadgets. So suddenly you will feel like this quote is so true that we are indebted to the few people who have worked hard to give us the knowledge today. And here you can see, Sir CV Raman. This is a photo from the Nobel Foundation archive. And we can see the spectroscope on the right, which Sir CV Raman used to have discovered the Raman effect along with his student, Krishnan. So, uh, I would like to talk about, how appropriate this is that Sir CV Raman got this. So first of all, Nobel Prize is a prize which is given to someone who has achieved excellence in a field. Someone has to be master and excellence in this field. Only then you get to go to get a Nobel Prize. The first Indian to get Nobel Prize was Rabindranath Tagore. Um, After that, first Indian was Rabindranath Tagore, and the next Indian to get this was Sir CV Raman. And till now, if you look at the 5 people who lived in India and got the Nobel Prize, were only 5, and the only person was Sir CV Raman, who got this in physics. There have been other people who have been people from origin of India, but they started to live abroad, who have got Nobel Prize in science. Particularly, one is Subramaniam, Dr. Chandrasekhar, who was a notable Indian astronomer, who was also the son of the elder brother of Sir CV Raman. So imagine, एक ही family में, in one family, they got 2 Nobel Peace Prize awards for science, and hardly any other people have got. Though there is one more award. So what we can learn. So for me, the take back from this study of life of Sir CV Raman is his consistency. He was consistent in his character throughout. So how can a scientist be consistent? See, the truths of nature the scientist is trying to find. Sometimes the older knowledge is replaced by new knowledge. But Sir CV Raman understood this, and he continued to research. So his one of the things you will find consistency was love for nature. He was passionate about light. He was passionate about science. He was passionate about he had this childlike enthusiasm for science, which and nature particularly. So wherever he stayed, he ensured there is a garden, or he would plant saplings. Till the end of his life, you would find that there is a particular consistency. Second trait of Sir CV Raman was loyalty to his country. So he wanted to build a place where youth could conduct research. He wanted India to have a culture of science where people could meet, share their knowledge. There could be libraries and journals and places of meeting. There could be academic places where the research could be done. So what is research? Sir CV Raman said that when we answer a question, when we ask a question and we have a seeking mind towards answering it, that is basically research. So he wanted India. He knew that India can only excel if we let science progress in India. This is why he was working so hard day and night. He fostered several capable students. He had a love for nature. I will talk about that love for nature again. And he had this childlike curiosity. So there is a song which is coming to my mind, which is there is a song where Farhan Akhtar, an Indian actor, sings this song. Asma hai neela kyun, pani gila gila kyun, gol kyun hai zameen. That means, why is the sky blue? Why is the earth round? And so on. If you add one more question to it, like, why is the sea blue? So all these, like, this is one of the questions he asked. So we have to, what we can take back from this is like, we have to have, you all must ask questions. So asking questions, like Sir CV Raman asked a question on a voyage in 2020, in 1921, on a voyage from England to India. He looked at the Mediterranean Sea and asked, why is the color of the sea blue? And it turned out no one had properly answered this question before. And that led him to win a Nobel Prize. So his communication, it was very fast. That means he would, whenever he made a discovery, he would explain it to others without waiting. He would publish scientific papers. He would, talk to others. He would give lecture to others. And his autonomy, that means he made a lot of decisions in his life. For example, in those days, one of the decisions he made autonomously is when he had to get married. And, in those days, it was a tradition that parents would, choose the spouse. And but here he met this wonderful lady, Lokasundari, and he knew that his father would consent to his wedding. And, he took his autonomous decision, and his family definitely supported. So, today through this talk, one thing which has very struck me is that this talk is about life of Sir CV Raman, why he's the the person who has brought that reform in India in science. It is also about when we talk about light. So there was a quote by some scientist. I was looking at it in the morning, that the when you actually science is also when you look at the same things through different angles, you get to learn about that thing. So I don't have that, like, I just missed that quote. Let me just share with you. Yeah, I have it here. Yeah, just a moment. Yeah, so the greatest discoveries often lie not in finding new things, but in seeing familiar things in new ways. So I hope today when we talk about it, you will be learning about light in a new way. When I talk about the physics behind the Raman spectrum, so you will be able to learn about what is Raman spectrum, why is it so important in our life. So I hope you will be able to see light in different, from a different angle. So here is National Science Day. Is such a joyful activity. You can see students from all over India participate every year in the schools. Thanks to the teachers who make them prepare them. And these the above pictures are from all over India. And the bottom row of pictures you are seeing is from Space India students. Space India has been conducting a lot of science activities ever since its founding. We have, reached to till now. We have touched more than 5 lakh students with science. Here you can see some of our National Science Day activities. Wonderful kids at the bottom left holding a National Science Day. And there is a telescope where, so one caution is there. You should never use the telescope to look at the sun. So here we are celebrating astronomy by looking at the sun safely through a filter. Okay, so please remember, safely through a filter, we are looking at the sun. Otherwise, never to look at the sun. Okay, so here is Sir CV Raman with children. So he is, surrounded with so many children. Again, a beautiful photograph. This is in his later years, when he was quite old. And, one thing very amazing. Okay, I find that my PPT PowerPoint is not shared. So what I'm going to do is sharing that. So I'll just take you through the slides here. Here I was talking about, I hope the slides are visible. Let me just be sure. So just
Yes,
to be
sir.
sure.
Yes, sir, they are visible.
Okay, thank you, thank you. Okay, thank you. So I'll just show, this is Space India's activity at the bottom, and you can see such, students holding science fairs, the hallmark of National Science Day, celebrations. This is an occasion to celebrate science. And today is, we are paying a tribute to Sir CV Raman. So just a moment, the pointer is not working anyway. So, okay, so you can see, just a moment. Yeah, so this is Sir CV Raman. As I was talking about him, this is a photograph of him, and this is the first slide where I shared that this is a photo from the Nobel Foundation archive, and the spectrum, spectroscope on the right, an instrument he used. So yeah, this is a beautiful picture. And Sir CV Raman says the pursuit of truth and beauty is a sphere of activity in which we are permitted to remain children all our lives. So, that is the joy of science. Everyone can relate to it, and particularly children, they are very curious. So they are very happy in this picture, very joyful, and we in the middle also we have a child standing. So Sir CV Raman is like a child because he had this childlike curiosity till the end of his life, and he also used to teach science in a very simple way. So he would make concepts very, very simple. Once he was like, as if a child could understand. So like he was explaining a concept about his discovery of Nobel Peace Prize and the Raman spectroscopy, and first at his mother thought that he's just saying something very far fetched. But then when he explained her again, she said, wow, it is so simple. So the way he created this revolution around him, that everyone was left like, wow, as if I'm present in with Sir CV Raman and conducting that experiment. So this is what people felt, and people felt like, wow, this was why his mother thought why this discovery was not known earlier. So this is a Raman tree. I talked about Sir's love for nature. This is a Raman tree. So the story goes like Sir CV Raman, loved like he loved beauty in nature. His favorite pastime was to do walk in nature. He used to plant trees. When he became the director of Indian Institute of Astrophysics at Bangalore, the first thing he did is plant trees and saplings. And he also planted a papaya tree because it gave sweet fruits. So here is a Raman Research Institute, India's. This is basically a cover from the newsletter of Raman Research Institute in India in 2022. So basically what has happened is this tree was planted in exact place where he was cremated. Now you can see a beautiful lawn is part of the Raman Research Institute. It was a privately funded institute by Sir CV Raman. And he all like his love for nature. He believed like the true education is something which cultivates a love for beautiful. So this tree is Primavera in 1988. By a strange coincidence, on 28th February 19, 1988, it blossomed. So this was planted after he died, somewhere in 1970s. 70, I don't remember the exact year, but this blossomed only twice, as I understand. Once this golden crown, which is so beautiful, on the occasion of the National Science Day. And once when the Raman Research Institute completed its Golden Jubilee. So he had this love for nature, and he would, yeah. So going to the story, in 1988, Sir CV Raman was born in Tiruchirappalli in Tamil Nadu, and here there is an ancestral home you can see, and this is the place. This is the room in which he was born. He was born to his parents, Dr. Ramanathan Chandrasekhar, and mother um, um, Parvati. Mother's name was Parvati. He had 8 siblings. His one of his brothers was called C.S. Chandrasekhar Subramaniam. Um, so from a very young age, he was actually very fast learner. So you give him, like, his father There was a mic, the mic got somehow. Okay, so this is the slide I was showing you. This is the book Light of Asia, which was about Gautam Buddha. So he was really inspired by Gautam Buddha. And, one of the incident when he was a child, his father was working as a professor of physics, I was mentioning. And what happened is that he, even one day when he was not well, Sir CV Raman was not well as a child, he asked, that he was waiting, curiously for his father to come home and get one of the lab equipments, which was called a bell jar, which used to store electricity. So he waited the entire evening, even in fever, and he took that bell jar and he saw, conducted experiments with electricity. So, he was so fascinated. And, he was always ahead of his classmates. He was very bright. He would ace. In his later years, you will find that he got so many medals. He cleared his matriculation at the age of just 12. And then even he cleared his college by 1907, which was at a much younger age, as compared to the others. So one of the things I want to tell about Sir CV Raman is that he had he wanted, okay, so okay, we can see here Sir CV Raman as a college student. His mother used to say, he has such a big head but a small, his grandmother used to say he had such a big head but a small body. But he used to say that, she used to say that he, in his big head, he houses his intelligence. And you can see you will find him in turban always. Just jokingly, he would say that he's wearing turban so that his head doesn't get any bigger. So this is 1907 was a very important year in his life, which was a turning point. So he loved science. In 1907, couple of things happened. So first of all, I want to go back one year, 1906, where he was in college. One thing he didn't like in the college was that there was no culture of conducting research. That means there was learning, but there were no labs, no research happening. No one used to encourage seeking answers to original questions. So what he did, he started on his own, and one day he went with a very interesting result to one of his professors in college. He joined the same college where his father had been teaching, and he gave him his paper. Paper is basically, you communicate a scientific result to the world. So he asked him to go and, his professor didn't bother much. And when Sir CV Raman asked, did you like the paper? He didn't, he discouraged him. He said, no, it's nothing special. But he didn't get discouraged. Sir CV Raman didn't get discouraged. He was confident that it's a very important research. So he went, and there was one of the very topmost journal in abroad, and he wrote directly. He went to his grandmother. He asked her, should I send it directly? Grandmother said, if it is not required, then you go ahead. And he sent this research paper directly, and it got published when he was in college in 1906. And Sir CV Raman in 1907, you can see he took up a job after graduating as accounts assistant general with the British. He was part of the British India, and there was no one pursuing scientific career. So the best option to earn money was to become an accountant at British, which would pay him some money. However, he loved science. And the same year, 1907, he got married to Lady Raman. Her name is Lokasundari. So, every person, every man likes, the wife would be the most beautiful. So she is Lok Sundari. And, you can see, actually, when he met her the first time, she was playing music in her veena, which you can see on the right side. That attracted him. Why? Because, he loved music, and he wanted to do research on the music also. So, when he saw, he just fell for her, and, they eventually they got married. So you can see on the left, Sir CV Raman with his wife. And Sir CV Raman, it's here I must mention that in his family, there were also people playing music. He conducted a lot of research. Research with respect to music also. In fact, there is one place where his wife was playing the this veena at home, and he went to her, and he explained that the Indian music instruments give you tones which even physicists say are not possible in a musical instrument. So he explained that this is happening because it is kind of violating the laws of physics given by the people. However, imagine that this, like, what he was trying to say is that the Indian physicists knew better, who had designed the veena. Indian musicians knew how certain tones can be produced, certain sounds can be produced in veena. So this was too good. And and then in 1907 he joined, after completing his college degree. He joined this as an accounts general. And then what happened is there came a turning point in his life, where on one day he was going on a tram to his returning from his tram and he passed this office, Indian Academy of Cultivation of Science. He noticed and a board, and he immediately got up at the next stop. He went there walking quickly. He knocked at the door. It was opened by Sir Ashutosh Day, who was the lab assistant. And he asked, he went inside, it was a lab. So he asked, when he went inside, it was like a dream come true for him. He wanted to work as a scientist, and he immediately said, I want to work here in my evening hours. So Sir Ashutosh Day, and also the person who had started the Indian Association of Cultivation of Science, uh, the son of his son was also there. And he said that we have been waiting for a person like you. And they said, will you work here? He said, yes, I want to work here. But they couldn't pay him money. But he said, all the lab equipments are all we need. So imagine, no one has used this lab for many years. And Sir CV Raman told them that, don't worry, I am here now. So it seemed indeed that the study, so, he said, don't worry, I am here now. And the people will, now it will start to be occupied. And exactly it had happened. So, this is in Calcutta, Bao Bazaar Street. It seemed that the study of light scattering might carry one into the deepest problems of physics and chemistry. It was this belief that led to the subject becoming main theme of our activities from Calcutta from that time on. So here, Professor CV Raman conducted research on light scattering. I'll explain later. This is this is Mahendra Lal Sarkar, the founder of IACS, who had built this lab in hopes that one day young people would come. He had said that people will automatically come, young people will come, and that's exactly it attracted. So he was kind of a chosen one whom they have been waiting for. And so quickly I want to mention about astronomy. Sir CV Raman also was gifted a telescope, a 7-inch telescope, with which he used to look at Jupiter planet. He could not get a lot of time. He said, I would unhesitatingly choose a life of an astronomer in the next life. Someone asked him, what would you do in the next lifetime? He said, I would unhesitatingly choose a life of an astronomer. Indeed, that has been one of my unfulfilled ambitions in life, to be a stargazer. So he promoted astronomy. He went in US and made it a point to visit the largest telescopes available there. 100-inch Hooker telescope. There is a beautiful telescope you can see in the dome. And he built an own observatory at the Indian Association of Cultivation of Science. So here he is with Sir Chandrasekhar, Sir Chandrasekhar, his own nephew, who was also an astronomer. So he loved his, he appreciated him, and he was very keen about his discovery about, he had discovered like the stars, like how the life of the stars. So for which Sir Chandrasekhar, Subramaniam Chandrasekhar, had won a Nobel Prize. So here, so one more interesting thing about his life is that, he created the right circumstances. See, he was traveling world over. He knew the latest going on in the science. So I talked to you about, keeping an open mind, but how does an open mind come? First of all, when you read a lot, like reading books was an important habit. So reading books give us that knowledge and that imagination necessary. It gives us insights into the laws of nature. So he was also meeting the top people. So it is said that here he is with Neil Bohr, a very important scientist, and on the right hand side he is with Werner Heisenberg. So it is said that the discovery of Raman effect was the essential proof which one very essential theory of physics, which was called the quantum physics, was needing. So his discovery actually proved quantum physics. So how is this happening? He was traveling around the globe meeting scientists. So here, here it is. A quote is given. Sir, the Raman effect, whose explanation uh, we s- uh, explanation agrees so well with quantum theory, will undoubtedly become a vital source in growing our knowledge of the state of atoms or molecules in transition, between which their characteristic spectra are emitted. I'll try to explain you, in a simple language. Here came the second life transforming moment. Now he was, visiting England to give a talk, and while coming back from there in 1921, so this is the route he followed. When the ship from London was following the path to India, on the way back, you can see the top path is taking them through the Mediterranean Sea. This is the Mediterranean Sea. And he noticed something, that the Mediterranean Sea was blue in color. Here is a beautiful. Now why was this blue? This fascinated him. So even if you look at the sea, you must have wondered, why is the sea blue? So no one had given a satisfactory answer till then. The most well-known explanation was till then given by someone called Lord Rayleigh. Lord Rayleigh was the person who had explained the color of the sky, why the sky is blue. And Lord Rayleigh himself said that the sea is blue because it reflects skylight. So I want you to think for a moment, can this be true? Look at the sea. If you look at, you can think of answers which will tell you that this is not so. For example, like if you take simple glass of water, it is transparent. And when you look at the reflective surface, on the top, when the light is reflecting, it doesn't, like it, the color of the sky it reflects doesn't agree with this. So I think by looking at it, you can see there is something deeper happening. So I'll do a quick demonstration so I'm going to do a quick demonstration here. So with a light, to show you what I have is what he was carrying with him, something I have right here with me. And let me show you. I'll stop sharing my screen. So I'll do an experiment which he did, right, coming from, this is something called as a polarizer. So what's going to happen is, let me show you. So as I'm going to share my camera screen right now, and now you can see I'm pointing my phone to my screen, and here is a polarizer. Now you can see the center part is black, but now I'm turning it. So look at it. Now it's passing light, but if I turn it, the light blocks. And yesterday I took it out from some device. Now I'm going to show you something. He conducted an experiment right in the Mediterranean Sea when he was on a ship coming back to India in the Mediterranean Sea. Now here we have a glass, and you can see we have my colleague Shahrukh holding a torch above it. And at the bottom, you can see that the glass is reflecting the light. So now I'm going to show you. Now you can see two dots, one above, that is the torch light, one below, that is the light of the torch reflected in the water. Now you can see something is happening, that when I rotate this, the torch light doesn't go dim, but the dot below it vanishes momentarily. So why is this happening? So what he took a very simple idea. Thank you, Shahrukh. So he came up with a very simple idea that if the sea was reflecting the sunlight, and if you could look at the sea from this device which he was carrying with him. So, you know, same way, the surface reflection would be cut off. So, because I told you, like, it was believed like sea is reflecting the light of the sky. So he, with this simple experiment, he cut off the reflected light and still see that the light which is coming from the sea was still deeper. So he gave a, and before he reached the the what you call um, the harbor, he had written a paper, and at the harbor he had sent the paper to a very renowned journal, and which got published. And this is where we learned that the color of the sea is blue, because not of reflection of light, but of some phenomena, same phenomena which we see in the sky. So I'm going to rush because I think there is a lot. Here is another blue color. This is Lord Rayleigh. This is showing you even in deep ocean, the color of the sea is blue. So we learned the color of the ocean is blue because the blue light is reaching the ocean depths. You can see here, red light is not reaching the ocean depth, yellow light is not reaching the ocean depth. This is 50 meters, this is 200 meters, but blue light can reach depths of the ocean. The other lights gets absorbed, but the blue light scatters inside the ocean. The same way the sky appears to be blue, the molecules and the dust in the sea scatters the light inside the sea and makes it blue. And here, after returning home from that voyage, he continued his experiments. And this is 1921. He's seen with a spectrograph. I'll show you a spectrograph in a moment. So today I'll also encourage you to do some experiment with light, which I'm just going to show you. So here he is with his students at the Indian Association of Cultivation of Science. You can see here is a instrument at the left, which he had constructed. He and his student Krishnan conducted a lot of experiments by passing single colored light through a liquid, and this is the award winning. Now you might not immediately understand until I explain you what this is. So what this is showing, this is showing you some lines. This happened on 28th February 1928. They recorded these lines. What they did, they passed some light. I'll explain you in a bit. They passed some light through a sample. I'll explain you. And they recorded the spectra. This was the discovery of the Raman effect. And this is the spectroscope he had got for this, which made the discovery. And here he is standing at 1930. He immediately published his discovery so that no other scientist could do it that fast. Here he is, so with other scientists. And quickly I want to share a story that if you look at this picture, please look at the flags. Which country's flag are you seeing upstairs on the top? The Sir CV Raman is sitting on somewhere on the stage on the extreme left. You can see certain flags. Look at the countries. Can you see India's flag? No. So he cried. He looked at all the other people who are getting the award with him in 1930 that day. They had their flags behind them. So when he looked at his back and he found there is no Indian flag there, he cried. He said that, look at my poor country. We don't even have a flag right now. This is Raman, Professor Raman. He immediately started to give lectures on after 1930's discovery. About his discovery here, he's seen. And later, he left the Indian Association of Cultivation of Science, and he joined the India's premier institute as the first director. Now, Indian Institute of Science, if you ask anyone, which is the topmost institutes in the world for science, in top 200, it is standing at 48th number last year. He became a director, but then he had to resign for certain reasons. This is Raman Research Institute he founded. He wanted to do research independently, unobstructed by any politician. So he said, like, science should be studied for its own right. Now, this is Raman Research Institute in Bangalore, his own institute. This is also one of the country's premier institute if you want to study science. And here is his collection of crystals, which he used to study. And here is Sir CV Raman with uh, um, Pandit Jawaharlal Nehru, who also promoted science. And one day, his daughter Indira Gandhi had visited Raman Research Institute, and she saw and she was amazed. So Raman asked him, "Please tell your father to come and see the lab." So Jawaharlal Nehru supported Raman immensely. Raman, there is a lot of story, but I'll keeping it short. So he is demonstrating some experiment, and here is a wonderful photo. Look at the confidence of Sir CV Raman, and he's meeting the Pandit Jawaharlal Nehru. And you can probably recognize the person standing in the picture. This is Mahatma Gandhi, father of the nation. He used to come to Calcutta, and he was invited to Raman Research Institute, and he came there. Provided, he said, like, if Raman is going to show me magic, science is magical, then I would come. So he especially came there, and Raman really respected him. Here he is with the father of Indian space program, Dr. Vikram Sarabhai, at the Indian Institute of Astrophysics. And he encouraged women in science. This is one of the women encouraged by Sir CV Raman, who went on to become the leading um, meteorologist, a weather scientist in India. And these are the, so I'm talking about, so I will be this is the last photo of Sir CV Raman, and some beautiful thing is happening. He is holding a flower in his hand, which shows his love for his nature. And continuing, so now what is the Raman effect? Here we can see a beautiful rainbow in the sky. You can see, rainbow is forming opposite to the place where the sky, the light from the sun comes. And we all in astronomy call it a spectrum. So you can see, it was discovered that, sunlight comprises of all colors, like the Vibgyor you call. So you can see red, orange, yellow, and so on. Okay, I have a question. Now let's go back to scattering of light. So here is moon. Now, interestingly, the moon sky is black even at the daytime. You can see the sky is black while the earth looks blue. It's daytime because I can tell, because the moon is showing you sunlight falling on it. Now, if you look at this, another picture of the Earth always looks blue from space. We call Earth the blue planet. And this blue reason was explained by Sir CV Raman. Now you can see the sky is blue. And the wonderful thing, how is the sky blue? So here we have the rainbow. We call it the spectrum. You can see some numbers attached to it. Now imagine if you take a string or a rope and you vibrate it. So if you vibrate it with a lot of energy, you will have to do up and down a lot of times. Okay. And suppose you give it less energy, so you would go up and down, up and down. So the wave is getting less energy. So the color red is like, okay, first of all colors are basically representing some energy. So the red color here is basically showing less energy. The waves, because light is like a wave, just like if you drop a stone in water, it creates ripples. So the red color is also a light. Light is like a energy carrying wave. Some people call it photons. So red color has less energy, while the violet color has high energy. And the number is given somewhere here, like 740, 435, and so on. All the colors are in between. This is, astronomers call it as the spectrum. It's nothing but the rainbow, just a fancy word for a rainbow. And I'll just show you how I can obtain a spectrum. Just that. So before I get to the spectrum, look at this. Why is the sky blue? So now it's time for me to show you a spectrum. So I have a spectroscope with me, and I am going to use my phone. First of all, I'm going to stop sharing the screen. And now you can see what I'm going to do is, we need that light. Upar wala light dena. And give me the spectroscope. Just a moment, people. Okay, just a moment, Yeah. Yeah. So now I am looking at, let me look at a light. So I have a spectroscope here with me. We just made it ourselves to keep things simple. Now, this is nothing but like some kind of prism is here. And now I'm pointing it to the light above. And if I look at the sides, you see the beautiful colors. The beautiful colors are not inside this. Just a moment. Is my sound going? Okay. So basically, you can see. Sorry if my sound was missing. So
No, sir, it was there. You,
okay.
it's
Thank
well.
you. Thank you. So you can see right now I'm taking a spectrum of the I'm taking a spectrum of the light, white light above, and you can see all the colors are there. Okay, so this is a simple device, and Sir CV Raman also, you conducted a lot of his discovery was related to this kind of device. Spectrum is just nothing but it's like, suppose you are seeing white light, but this is dividing the light into its what the colors are made up of. What is those colors? So the spectroscope is actually looking at, oh wow, all the colors are present. So spectroscope is like a detective which is telling us what exactly is that light made up of. um, and I will show you just something like a scattering of light here, because I'm going to use this word. Now you can see a glass of water, and my colleague Shahrukh is explaining, and I have a wonderful rainbow. So you can do this experiment at home. Just take a torch, because okay, I can see a rainbow right here, beautiful. Yes, Shahrukh, थोड़ा सा हिलाना इसको. Yeah, you can see on here, I can see colors. I don't know how good they are visible on the camera, but I can see. Uh, yeah, okay, I can see a lot of fringes. Like I can see red and blue. But okay, this is white light, and white light can be divided into, white light is comprising of so many colors, and this is obvious when the light is passing through. On the other side, like prism breaks down the light. That's what you are going to see. Prism breaks down the light. It's like some part of the light getting broken into rainbow. Now I have a laser beam with me, and that laser beam, when I shine through the glass of water, naturally I am not expecting anything other than a, green light. So this light is passing through water, and on the other side I'm getting green light only. Nothing unusual, because imagine that I have balls of different colors, and suppose so basically what is happening is, okay, when you look at white light, it broke down into colors, but why is green light not breaking into different colors? Very obvious reason is that white light was initially comprising of those colors, and so it would break down into colors when it passing through glass of water like a prism, but here the green laser is comprising only of green color, so it cannot be further divided. So it's something we call it monochromatic. That means being of a single color. So what? Okay, so let me now show you a scattering effect. So scattering, I'll show you on the left. You can see a beam scattered in the water. You can see right now there is beam of laser passing in front of this camera, but you can't see it. But if I pass it from the water, you can see that it is getting scattered. Scattered means just like if you take a billiard ball and hit it, hit like a group of billiard ball with one billiard ball, what's going to happen? The whole group will shatter, and everything is going to go in different directions. So what is happening is the tiny particles of dust in the in the water, or tiny whatever is there in the water, is basically scattering the light in all directions. That is why we are able to see light beam which would have been otherwise invisible. Now, why are we seeing? So what did, okay, so coming back to the slides here. Okay, we come back to the slides, and just a moment. Yep. So you can see light getting scattered. When you see dust is there in a cathedral on the right, and the sunlight is coming and it's getting scattered. It's looking white because of the dust particles. So what is happening? On the left, we are explaining that the sunlight is
Sorry, sir.
comprising of.
Sorry to interrupt you. Can you please turn off your phone video and turn on your video from the
Yep.
main
Yep.
chat? Yeah.
Yes.
Okay.
Yes. Of course. Yeah. Okay, thank you. So you can see right now, this is Earth's atmosphere. We have shown you the blue color, and the light from the all the colors of the rainbow are entering it. But what is happening? See, atmosphere is made up of tiny droplets, tiny particles, which scatter blue light, but not red light. So red light is going uninterrupted. So what is basically scattering? I explained you when the light does not preferentially bend in one particular direction, but it can bend in any direction. This was explained by Lord Rayleigh. He explained that the amount of light which scatters depends upon the wavelength or the energy of light. So you can see the bluer light, he explained this is why the blue light will scatter more, and you can see that is exactly what is happening. So when you're looking at the Earth's atmosphere, the light is coming from all over. Even when you're not looking at the sun, if you look at the other direction, it doesn't look black. It looks blue because the particles are coming in all directions. So this is something we call it Rayleigh scattering. So only blue light is entering, and blue light, the light entering is the same as the light output by the atmosphere. Now let's see further. So we've understood, this was explained by Lord Rayleigh, and this is also the reason why we see sun as yellow in the afternoon while red in the evening. You can see as the sunlight is passing more and more, as it passes through a longer path in the evening sky. You can see on the diagram on the right is showing that it's passing through a longer path, while in the noon time it is going only from above the head. So as it passes more and more through the longer path, the more and more bluer and even yellow light gets scattered, and what we get is only red. Okay, so right now let's understand what is we understood what is Rayleigh scattering. Now let's understand what is Raman scattering. So according to Rayleigh scattering, it is the particles which is scattering, but in the Raman scattering, it is the molecule. So if you look, the beautiful world around us is made up of uh, thousands of compounds, actually millions and trillions of compounds means just molecules. So if you play Lego blocks, there are limited number of Lego blocks, but it can create an unlimited number of combinations. So similarly, nature has a building block. Wonderful thing is our body is made up of compounds, elements, and we call this, you can call it molecules also, or you can call it atoms also. And there are, as I said, there are innumerous. We know about 350,000 substances in catalog, but otherwise, in nature, there are which we produce in probably some kind of factory or in which we make. But in nature, there would be many, many. But the interesting part is each of those chemicals is each of those chemical compound is structurally. That means uska jo design, its design is different. Okay, so this is the basis of Raman spectroscopy. So you will understand what is Raman spectroscopy. It is used in airports to detect elements. So imagine if you want to know what material. Suppose I have a powder. If I ask you to test it without tasting it or without smelling it, but without destroying it, we know one very good way called Raman spectroscopy, the science invented by Sir CV Raman. So here is a model of atom. It is at the center of the atom is tiny nucleus or the positively charged protons, and this is a very simple model of atom in around which there are negatively charged electrons there. Now you can see simplest atom on my left is hydrogen, and the electrons, that means the negatively charged particle, just like planets, I'm giving you a very simple explanation. Just like planets, it can orbit the central nucleus. Now imagine if you are some kids there, imagine yourself, if you are having more energy, you will jump more. If you are having less energy, you will probably go to sleep. So what is happening with the atoms is that in the atoms, electrons want to rest, be at rest. That means there are many orbits possible. For example, 1n, 2 and 3n. There are many possibilities there. Electrons in a hydrogen simple atom, that means like the tiniest particle of nature. the electron will always try to stay at the lowest possible energy level. Okay, it's like saying if you jump, you are going to come to the ground only. So, but you need energy to go up. You need energy to climb stairs. The higher the floor, if I ask you to climb a floor, the higher you go, the more energy you need to climb. Okay, but you can't stay at a building top always. You will eventually come down. So what is happening is, so I'm explaining you are going to become quantum physics physicist in a simple language. You will understand one phenomenon of quantum physics. So what is happening is, the electron will always be found at the lowest energy state. Energy state, I'm calling it. So just like just like the energy when you jump, you reach a higher level, you have that more energy with you because you are at a height. Okay, if you have any questions, you can ask me later. Now, what is happening when light comes? I'm giving you one explanation. There could be something different happening. I'm not giving you a universal explanation, but what is one possibility when light coming hits a molecule of an atom, hits a molecule or an atom, it can give that energy to an electron. Now, please see. Now, one thing about quantum mechanics is like quantum, I'm using heavy word, but I'm explaining it. See, if I give energy to this electron, it can come here. Or if I give more energy, it can come here. But eventually it will fall down and give back. So I cannot give it, the electron can never be found in the middle of any two orbits. Okay, electron can be found here, 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 but it cannot be here, it cannot be here. So only particular energy I can give, and this energy absorbed by photon is electron is called a quanta. That's where the word quantum physics come from. And here, when a light packet interacts, if just the energy is just right, so it can jump from here to here and gain energy, absorbs the energy, or it can even go here and absorbing more energy. And so it wants to go back, it will fall down and it will release the energy in the form of light. So what is happening is, suppose I give it blue light and it gets excited, absorbs the energy, comes here. When the atom momentarily, it will happen in a fraction of a second. This can happen many times in a second, trillions of times in a second it can happen. That electron will fall back, giving that energy back. So it's like saying I have a ball here. Okay, so suppose I'm going to bounce this ball from the floor. Can you give it back to me, Shahrukh? Yeah. So I made the ball bounce. So ball bounces, it comes back, so to say, with same amount of energy. It's like same energy given to the ball comes back. Sometimes, this was always understood. Okay, whenever you see light, when it passes through material, it will not change its color. But what happened, what was discovered by Sir CV Raman and his student under his leadership, that, they found that a slight glow was there when they passed a violet light inside a beaker of some liquid. They found, some green color was coming. Where did this green color come from? It was not very strong. It was very weak. So what they found is, here you can see, when they, this will probably explain it better. This is liquid. They passed white sunlight through a violet filter. So it was just one color light passing through a liquid. It scattered. Now, what color do you expect it will be? It should be violet. But small amount of green color was there. That means some energy was shifted. Why this happened? Because he explained, now this was his genius, and this transformed the world, that, here, when once in a million, the atoms, when it comes, electron reaches here, I'm giving you, this could be any molecule or atom, it will fall back the same amount. But once in a million times, it happens that it falls less. It's like saying I keep a cardboard box down and I throw this ball. So this ball will not come at the same height, but it will come at a lesser height now. Some energy got absorbed by that cardboard. So instead of giving violet light of higher energy, it gave us lesser energy. So this is what he explained here. I will just skip this slide. So in Rayleigh scattering, it was the light of same color. If I give you a blue ball, you will give me blue ball back. But in Raman scattering, what was happening is if I give you a blue ball, you could probably once in a million times change the color of the ball at your end. You would gain that extra energy and give me a lesser energy ball. So this is a device. Was Raman sir. This was a spectroscope. He passed this was a telescope. He focused. This is a telescope. He focused. This is a spectroscope. And then he observed like light passing through a sample, and they detected other color. Now, this was by which he was awarded the Nobel Prize. And because this has a lot of implications, immediately after making his discovery, about hundreds of papers were published the same year. That means so many scientists recognized it. Now, here is its application. Why do you need it? Here is an example of a diamond. And you can see there is a microscope, Raman microscope at the left. And what it is going to do is shine light into diamond and look at this diamond, whether it is a fake. So we imagine two diamonds, one a fake diamond, one a real diamond. Now, what is happening is like this. So, each person has a unique signature or a fingerprint. So that amount of light which changes for each molecule is unique in the whole world. So this will change, like here it changed from violet to green. In one of the earlier slides, I had mentioned when Sir CV Raman had, so this is the discovery. So here, this was light of one color, but he discovered that very, very faint light of some other color. So they were not expected. But this distance between these lines is a unique signature. How much is this distance from this original line? So this is a character. It's like you can identify any person by signature. Similarly, imagine like you have signatures of all the known compounds, and suppose you know all the compound signature, and then you try Raman spectroscopy on any compound. What you can do is detect what material is there, and here you will see. We'll do that. So here is basically, this must be so technical for you, but this is just a spectrum. But we saw like the rainbow, but here I'm making a graph of that rainbow. So imagine this represents one particular color. Okay. Now this number is telling us, so this is like a signature. The real diamond has this signature, but a fake diamond, we know them to be very identical, but at Raman spectroscopy, it gives this signature. And if you know it, you can in 20 seconds detect whether the diamond is real or fake. And here is its one more application. Now this is Raman scanner. You are seeing it is as big as 1 foot, and it can detect medicines. It can detect the quality of your food, whether it is stale, whether it is fresh. It can detect if any person. So don't worry, it won't happen to you. People going to airports, sometimes they are called for a security checks, the serious one. So like suppose someone fears that there is some material someone is carrying. Just like you go to metro station and they check your bags, they tell so like what they do is, like in airports, suppose someone is carrying illegal substance, suppose so they can detect it without destroying it. So here the scientist is looking at a picture and detecting with it. And the good news is that now the Raman spectroscope has also reached space. On board Mars 2020 mission, there is this instrument called Sherlock, where Sherlock is, it's like a detective, Sherlock Holmes. So it is an acronym where R stands for Raman. This is a Raman spectroscope here, which can detect what materials are present on Mars. So Sir CV Raman's invention is now also in space. So thank you so much for your patient listening. And here I would conclude, and I would request you to ask questions so that we can proceed further. Thank you very much.
Thank you so much, sir.
Yes. Okay. Rishita, yes. So let's have the questions.
Thank you, Vikrant sir, for your insightful presentation. We really loved the demonstration, and it gave us a really perspective of the effect that you're trying to explain. Now, moving on to the next segment, we invite students to submit their questions through the provided Google form for our interactive session, which is pinned in the comment section. So now, as we wrap up this session, I am starting with the questions. Okay, so let's start. So first question is, what are other spectroscopic techniques other than Raman effect?
Okay, so great question. So one of the spectroscopic technique is where I just showed you the simple spectroscope. This is the most simple spectroscope, and this is, for example, I'll give you an example of how it is used. So suppose you shine white light or sunlight is falling on the leaves of a plant. Now, a scientist can detect the signature of this leaf. So leaf looks green to you because of presence of chlorophyll. But if you were to look at it carefully with a spectroscope, which is also not just the visible colors, but also infrared. Infrared is light just next to red light, which is heat. So you can detect, what you will find is very little blue color, very little other colors, but the green is maximum. Yellow is a little lower, red is minimum, minimum, minimum. Then again, it becomes another hill. That means more color of infrared comes then. So the green is reflecting light in, there is a way. So, it's an S-shaped thing you would see. So this is one of the spectroscope you have, which is there. So there are different kinds of spectrums also. So, this is one of the most popular ones because, this was discovered, even if you look at the asteroids, but the sunlight falling through it, you can detect what the asteroid is made up of. So, yes.
Okay. Okay. So thank you for answering, sir. I hope it helps whosoever has asked this question. Now, moving on, there are a few more questions related. Can you shed light once again on the principle of Raman effect?
Yes. So the Raman effect, as I explained, is basically the shifting of light. So I gave you an example of, I'm giving you a very simple example. Suppose, so Shah Rukh is sitting here. I'm giving him this ball and let him throw back to me. So I suppose this is a yellow ball. So I gave him yellow ball. Every time he's going to give me yellow ball. Now, depending on his preference, once in a million times, he can throw me a different color. So now I'm finding that this ball once in a million times of a different color. So this is according to Shah Rukh's preference, my colleague. Similarly, the Raman effect is talking, there is a shift. So Raman effect is nothing but that change in the light color or the energy, because astronomers, we not just look at the light as colors, but as energy, blue being the highest energy, red being the least. So that Raman effect means the change in the frequency of the light. So it can sometimes be higher, sometimes be lower, as I explained. And it happens because when the light excites the molecule, all the times it's going to, the energy it acquires, it gives it back. So basically what is happening is, you have to understand light is like a, what is light basically? So light is nothing but electromagnetic radiations, electromagnetic radiation. And so we were looking at, when we looked at that laser light falling, what we could have discovered, if we had, there is a Raman effect going on there. Suppose I'm shining light, I'm taking the camera and I'm shining the light on the, let's say, the roof. Now what you're finding is green light. If you look, so light is getting scattered by that surface. Okay, laser is giving green light, so you can't expect, but tiny portion of that light is also of a different color, which can be detected by very sensitive Raman spectroscope. So this is the Raman effect. So, yeah, in case you want more, I can tell you more, but let's take the next question.
Okay, thank you so much, sir. It was literally very helpful. Okay, so now there are a few questions related to, like, are there any limitations to Raman effect or any demerits of the same principle?
Yeah, so one of the demerits, I know a couple of them. One of them is that it is called as the spectroscopy, which is non-invasive. That means it doesn't go inside the sample. It it is said that it doesn't destroy. One of the things is, like, people have noticed that it can destroy some part of the sample. So because of the heat effect, it can transform some molecules. Second is, like, the spectroscope. This one is not an inexpensive one like the actual spectroscope. It is a more expensive spectroscope. Like this is, I could build this one, but the sensitivity required and cannot be expected. Then the other thing is that sometimes you need to detect only very trace elements. Suppose, um, okay, let's say someone, some bad person is on the airport, and he had some medicines which are not good for everyone. Suppose he has handled them. Now suppose he would have some part of that medicine. In that case, we are not able to detect because Raman effect is a very weak effect, so it would not work there. Okay. Yep.
Okay, so now we have talked about the limitations, but can we use Raman effect in our day-to-day life? Is there any application related to that?
Well, I am aware that right now we are using one of the applications of Raman effect. As you know, people are all over the internet, and Raman effect is used in optical fibers. How? Basically, in optical fibers, also as the light is getting diffused or getting scattered, they are using some kind of Raman effect, which is used in amplifying. So, as the light travels long distances in optical fibers, it gets diminished. Raman effect helps us. Raman effect in some way, I can't explain in what exact way, but it does affect us. So that it is being used in day-to-day life in amplifying the signals of um, those optical fiber. Otherwise, it is used, what I understand, is used more in medicine. If you have a tablet, what kind of material is that tablet? So possibly, the tablets which you are eating, maybe sometimes in food checks, it is used.
Okay, okay, thank you, sir. Now, moving on to the next question. So, this question is now related to more of astronomy. So, would the
Mhm.
Raman effect be different on other planets? If that's so, then why?
Ah, well, I didn't understand the question because I think this should be an obvious answer, but still.
Mm.
So, see, okay, like one thing I did. Okay, I use this. Now, this is Sir CV Raman had used a similar thing, and we took a glass and showed you. So that experiment happened so many years back, but I can take this simple thing like a Nicol prism which he carried to a sea and check it for myself. Okay, I don't need to, it is the same effect that time and same effect this time. So the wonderful thing about physics, if I understand the question correctly, is the Raman effect would be the same, but just that because it is just scattering would happen on all planets. It's a physical phenomena. So if that is the question, then yes, the Raman effect or any physical law will be same all over the universe, not just any other planet.
Greatly answer, sir. Now, there is more question. Now, there is one question which literally intrigued me a lot. So, the why C.V. Raman was curious with tabla.
Okay, here we have a tabla. Well, we were thinking of the answers. So here we have a tabla. Shahrukh, can we have the dust? So I know that his family, we have put some mud over there. Something very interesting. He wanted to, in his family, there were musicians. His father had also taught music, made her music love, mother love music. So when he even went to the Indian Association of Cultivation of Science, he told that my experiments would be in the field of acoustics and the optics. So what we were trying to do is got us interested also. So, he asked a couple of simple things about Indian instruments like violin. He used to play. Possibly he was exposed to those instruments. So, what we were looking at, and we were not able to successfully demonstrate. But, when I, do this, there is certain sound produced. And, if you put just uh, like some mud or some powder and properly do this experiment and create different tones, you would see different patterns forming on this. Okay. Now, this is a way to visualize sound. So possibly, if you were to try, I were to try, I would also get interested in tabla. So that's the answer I can give you. Yeah, so acoustics is very interesting. And, if I were to buy, some of you are musicians. I know one of my musician friends told me he would be joining. So, the way, like he was also interested in knowing how, like the violin string, is made up of camel hair, it vibrates. So what is exactly happening? So once you, the idea is to get involved. And the what I would encourage is, see, if I can't give you the answer, but what CV Raman would say, Sir CV Raman would say, try out, don't give up until you know the answer. So this is what he tried to find out in acoustics, because his family had also exposure to music, and he loved musical instruments. So this is in brief what I can give you.
So literally, he
Possibly,
made his
yeah,
love for music and the love for physics together combined and made all of us proud today, I guess.
absolutely, yes.
So, sir, since you have such detailed history of Dr. C.V. Raman, so is there any incident which led C.V. Raman, sir, to love science? If you would like to share.
Uh, okay, any incident, particular
A-
incident?
Any
No,
incident would work.
okay, thinking. So, I can't, I'm just thinking, he loved astronomy. Um, any particular incident? See, we know
It
this one instrument, one thing which I was talking, which I talked to you about. The most important incident which happened is he looking at the Mediterranean Sea, and what we believe is when he was living in Calcutta, there was sea. He had access to sea, and uh, he used to say, I just want to tell you this, since you asked about this story. So I'll tell you that what he used to say. He used to say that I need sunlight, and I need questioning mind, and I need matter, and so the nature would reveal its secrets. So he knew that one day, just studying light. So he was living, he was, what I would say is, he was very close to nature. He loved colors. So I can't think of any reason why someone would love colors. We all love colors. But he was exposed to the sea right there. He was curious, and that time, as I told you, he was meeting the right scientists, the people who were talking about color, who were talking about atoms. So, he knew that the sunlight would reveal its secret. He loved, he always used to keep himself close to nature. He planted trees, as I was saying. He used to, in the last photo you saw the colors of flowers. So all this combined. So if you would say to one incident which transformed his life, was when he questioned that the color of the Mediterranean Sea, and it is vivid. If we went to Mediterranean Sea once in space when we conducted a solar eclipse, and I was amazed near Turkey what the beautiful blue color. So that would have been a life transforming experience. And he saw glaciers. So it was keeping himself close to the nature and experiencing it at phenomena like this, beautiful phenomena. And he
Thank
loved
you, sir. Totally
creating soap
agreed.
bubbles. Yes, one more incident which happened. So you can try this. Take a bubble. You all probably do this as kids. You take a soap water, take a straw, put water in it. So he used to, at his with his brothers, they created soap bubbles. So you see those rainbow colors, you can create a rainbow at your home. Yeah. So these all things inspired him. And today you can also do this experiment where you take a cell phone torch, and pass the light through it, watch it. So you are all budding scientists today. Pass it, and you would see a simple rainbow there. Yes,
So that means he had all his day-to-day activities related to science, right? So that
absolutely.
led him to this.
Yes.
Okay, so next question is how does Raman effect explain quantum theory?
Yeah, so basically one of the things is, what is quantum theory? See, I explained you that like at quantum level, what is happening is, like, atoms can exist at discrete states. That means, see, the simple fact that each atom is unique. So let me explain you, the atoms can exist only in certain states. So I'll go back to the slides. One of the most convincing proofs, he said, so of the quantum theory which came about. So I'll go to the presentation once again and take you there. So here you can see what I was sharing is what is a quantum theory basically is like the atom, the electron can jump from here to here, but it cannot exist here. So there is only a, so for each chemical substance, there is a signature which is different. So basically you would, this difference is nothing but an energy difference. Okay, here it is certain amount of energy. And when you look at the spectrum, it's certain amount of energy. So, suppose we know that an atom in compounds, what are the energy differences? Where all, if you shine a monochromatic light, single colored light, what all is possible with it? So, you know, you get a like a fingerprint which is right here. So this line couldn't exist here. This is basically telling you some quantum difference. Quantum means discrete. That means energy cannot, suppose I am like between 1 and 10, there are 10 integers, but there are innumerable decimal numbers you can have. But in quantum physics, there are just certain places or certain energy levels corresponding. So when this was so obvious that everyone thought like, wow, this was not discovered. So these differences actually correspond to those quantum states. And yeah, so I have, like in phone, I can only have 9 digits, 1, 2, 3, 4, 5, 6, 7, 8, 9, but no 9.5 or no 8.5 is there. So what, like similarly, those energy differences you see in the Raman spectrum are also the same. So this became like at that time, the quantum theory was very new. So, this became a very obvious reason. And today, yeah.
Okay, thank you, sir. So this will be the last question of the event. So since we are doing this on the occasion of National Science Day to honor his work, can you tell students how do they make their own spectrometer or any other related science activity so that they can understand Raman effect in their
Wow.
day-to-day life?
Okay, since you asked this question, I was also thinking, but since you asked this question, I won't plan to answer. But this is something amazing question. So here we have taken a tube. If you want to make their own spectrometer, what you can do is, if you still can find a CD somewhere, a compact disc or a DVD, which still may be found. Otherwise, what you can do is okay, I'll show you this tube. So what we have done is, this is, we have made two tapes. We have put one here and one here. Okay, and there is small gap. Okay, and rather what you do is, like, because you are doing it with a CD, what you'll have to do is you create a slit here. Okay, that means you cut some hole here. Imagine I have a tube, you cut a hole and you create a slit. That means you block the light, just let it pass. Two pieces of tape you stick. You leave this end open. You put a CD at diagonally here in front of this. So basically, suppose there is a hole, you put a CD diagonally and you observe from here, you're looking at a CD which is like this, cut inside the tube, and the light can fall on the CD and reflect it back to your eye. So what is happening is the CD has tiny, tiny uh, pits, just like, tiny, tiny pits. It's like each one of them acts like a tiny prism. Collectively, you will be able to see now to look at any substance or any light. There's a simple spectroscope. You can point, let the light come from here through this hole where you've created a small rectangular part about 1 mm wide. You look at any bulb and you will be able to see a rainbow here. Here we have used, so I can remove it. This is a little more difficult to make because this is something you will have to find. This is called a diffraction grating. It's like, um, we had it, so it's like tiny prisms, hundreds of them per inch. Yep. Or yeah, otherwise you can take a jar of water, put a mirror, let the sunlight, mirror is inserted in the water, sunlight falls and see the reflection, just like we created this. So that's also like a spectrometer, but just that you will not see those details, but you will see just a rainbow. Yes. So basically what is a spectrometer is, spectroscope is just like, now imagine that my colleague is here, so I'm giving him lots of colors of balls. I have all the colors. Now what he's doing is, now when he receives them, it's like all colors coming together. It's like white light. But what he does is, okay, yellow ball, he keeps it here. Okay, green ball, he keeps it here. Okay, blue ball, he sorts them out quickly, quickly, quickly. He keeps sorting them out. So now I can see which colors came. That is what a CD spectrometer or any spectrometer is doing. Meter is also counting the number of balls. Okay, so you can create it this simply. Yeah.
Okay, thank you so much, sir. So now, since we are at the end of the event, I would like to express my gratitude to Mr. Vikrant Narang for his valuable time and um, information today. Now, special thanks to all the students for actively participating in today's webinar that was facilitated by Mr. Vikrant Narang. Your engagement has truly made this experience enriching. So that is all from our side. And thank you so much for being a part of this journey. So we shall see you in the next such event. Thank you so much.